welcome to my YouTube channel. Today I'm solving Leetcode question 72, added distance. Given two strings word 1 and word 2, return the minimum number of operations required to convert word 1 to word 2. You have the following three operations permitted on a word. You can insert a character, you can delete the character, you can replace a character. In the first example, word 1 is horse, word 2 is ROS. The output is 3. The minimum number of operations required to convert horse to ROS is 3. The explanation is, first step, you replace H with R in the horse, and then you remove the R in the middle to convert it to rose, and then you remove the ending E to convert it to ROS. So 3 operations required. In the example 2, word 1 is intention, word 2 is execution. The minimum number of operations is 5. So you first remove T from intention, and then you replace I with E. You replace N with X, you replace N with C, you insert U. So 5 operations converting this intention to the word to execution. So how to solve this problem? Let's revisit the example 1. Let's say at the first character of the word 1, that is H. Let's say we compare this H with the first character of word 2, R, to see if they are equal. If they are the same character, then we do not need to perform any operation. We can just move on to the next characters in both word 1 and word 2. But in this case, H and R, they are not equal. So in that case, we need to try the 3 different operations. We could try, okay, insert a word. Maybe we can insert a R here. In that case, we kind of have a matching character. Or we can try, let's say, what if I delete this H? Would that work? And then we can also try, let's say, replace this H with an R. So for each operations, we can try. And then we kind of can find the minimum. Let's say we need to get the minimum number of operations. So basically, of all the 3 possibilities we try, we return the one that gave us the minimum number of operations. So that's kind of how we get our results. So you can see here, we can just break down the problem into sub-problems. So we start with the word 1 and word 2, and then we compare each character. And then once we perform an operation or we finish the comparison, we move on to the next character. So in that case, we break this problem down into the sub-problem. So we can solve it using recursion. And then to optimize the recursion, in order to avoid the repeated computation, we can use recursion with memoization. So the first solution I'm going to code up is the recursive solution with memoization. This is a top-down approach. So for the memoization, we use a cache to store the value we already encountered or calculated before in order to avoid repeatedly calculating the same value over and over again. And we define a sub-function. So let's call it helper, and then call it ij. So in this case, we are comparing the string. So basically, this one is return the minimum added distance. Basically, return the added distance between word 1 starting at position I and word 2 starting at position J. So this is our helper function ij. So the purpose of this helper function is to calculate the added distance between word 1 I and word 2 J. So we first check our base case. If I greater than or equal to the length of word 1, which means we have considered and checked all the index for all the characters in word 1. In that case, if we still have characters left in word 2, then we just return word 2 minus I. If our J is greater than or equal to the length of word 2. In this case, if we still have character left in word 1, in that case, we just return the length of word 1 minus I. So basically, if we have the character left for line 8, let's say if we have character still left in word 2, then we need to insert characters into word 1 in order to match the remaining characters in word 2. So insertion. If we still have the characters in word 1, after we visit every characters, consider every characters in word 2, in this case we need to delete all those characters. We need to delete all the remaining characters from word 1. So that's our base case. And then we start the comparison. So we check if I, J not in cache. And then we compare the word 1 I with word 2 J. If they equal to each other, then our cache I, J equals the helper I plus 1, J plus 1. So if the word, the character at position I in word 1, so word 1 I equals word 2 J, in that case, we have a matching pair. We do not need to perform any edit. So in that case, our result, the added distance, is just the same as the added distance between word 1 I plus 1 to the end, and then word 2 J plus 1 all the way to the end. Else, if they are not equal to each other, then we need to perform the added, and then we try the 3 different options. So I'm going to explain what I mean here. So we are performing the added. So let's say we may try insertion. We will try insert a character into that. So in that case, it's 1 plus helper So why this is the case? So let's take a look at the this example. From the here to here. So let's say in this example we perform an insertion, right? So at this position. So suppose before the insertion, we are consider the position at here. So this is our I, and then this is our J. So that's before the insertion. And then we compare the T versus this U, and we find they do not match each other. So what we are trying to do is we try to insert a U before this T. So after the insertion, I match the inserted character, match the character at index J. So we insert a character U and it match the character at index J in word 2. So in that case, for word 2, we can move to the next character to consider the match for the T. But here, for the word 1, since we insert a character before it, so our I still pointing to the original location. So that's why we need to consider 1 plus helper I, J plus 1. And then let's think about the delete operation. For delete, let's consider this one. We remove the T. So here we are at position I, and then we are at position J. We compare this I with J. So word 1 I is T, word 2 J is E. They do not equal to each other. And then here we use a delete operation, so we delete this character. So in that case, we need to consider the next character. Since we already delete the character at position I in word 1, then next we need to consider the character at position I plus 1 in the word 1 and compare it with the character at position J. Because in the deletion, by doing the deletion, we just delete the character at position index I from word 1. And then we need to move on to consider the next character in the word 1 and then compare it with the character at index J in word 2 to see if they match each other. So that's why it's 1 plus helper I plus 1 J. For the replacement, so for replace, that's easy. So we can take a look at this example. So here we replace I with E. So suppose our index I is here pointing to the beginning, our index J is pointing here. And then since we compare them, this character I does not equal to character E. So we replace this character with I with character E. And then in that case, we find a matching pair after the replacement. So we can move our index I and J both to the next character. So that's why it's 1 plus helper I plus 1, I plus 1, J plus 1. So that's the explanation or the breakdown for this line, the line 17. The minimum is we need to return the minimum number of operations. So we try the 3 possible operations and then we return the minimum. Okay, after the recursion, we just return cache ij. So if ij not in cache, we just perform the calculation. And then if it's already in the cache, so we just skip this if function, and then we just jump to the end and directly return from the cache. So this is our solution, recursive solution with memoization, the top-down approach, starting from the problem and then break down to the sub-problem. Let me run the code. Okay, so I made a mistake. So I finished coding up the helper function, but I haven't solved the this function yet. So I still need to call helper 0, 0, in order to return the added distance between word 1 and word 2. And then I just return it. Okay, this solution is pretty efficient. So we passed all the test cases, and it's faster than 95% of Python 3 submissions. So let me try to go over this solution one more time. So to solve this one, at a distance, we use a recursive solution with memoization. It's a top-down approach. We use a cache to keep track of the values we already calculated before to avoid repeated computation. This helper function is our recursive function we defined. It takes the input ij. So basically, it returns the added distance between word 1 starting at index I and word 2 starting at index j. So that's kind of how we break down the problem into the subproblem. So we consider only the starting position I and j. And then our base case is, let's say, if we run out an index for word 1, which means we consider all the possible characters in word 1. And then in this case, if we still have characters remaining in word 2, then we need to insert characters, this number of characters into word 1 in order to convert word 1 to word 2. If we still have remaining characters left for word 1, after we consider all the characters for word 2, in this case, we need to delete those remaining characters from word 1 in order to convert word 1 into word 2. So that's our base case for the recursion. And then after we consider the base case, we run the recursive steps. So we first check if this ij has already been calculated before. If ij is not in the cache, then it means it's not calculated before. So we need to calculate using recursion. So we calculate by comparing the character at position I and j in word 1 and word 2. And then we check them to see, okay, if they are equal. So in that case, we do not need to perform any operation for these two characters. We can just move on and consider the next the substrings starting from the next character. Else, if they are not equal to each other, then we need to perform the added operation. So in that case, the added operation we are going to perform is the one of the three. So we try the three options and then we take the minimum one. We plus 1 here because we perform one added operation here. So the added operation, we try insert a character, and then we use this example to illustrate the insertion. So basically, my I is pointing at the character T in word 1, and my J is pointing to character U in word 2. They are not equal to each other. So I insert U into the word 1. So in that case, after the insertion, this inserted character match the character at position J in word 2. So in that case, for J, I can move on to the next character because I already matched the characters at this position J, so I need to try match the next character. And then I do not move I here because in this operation, we compare the inserted character. We haven't really checked the character at position I in word 1. So that's why it's 1 plus helper I, J plus 1. For the deletion, we take a look at this example, intention to delete a T from intention. So in that case, we start with the I pointing to T in word 1, J pointing to E in word 2. And then we try delete this character T from word 1. After the deletion, we need to move on and consider the next character. So that's why it's helper I plus 1. And then this character at position in index J in word 2 hasn't been really matched. So that's why in this case J remains the same. So that's why for deletion is 1 plus helper I plus 1 J. And for replacement, since we replaced the character, we already find matching pair after the replacement. So we just move on. So that's why I plus 1, J plus 1, both of them move to the next character to consider. So that's the recursive approach. And then in the end, we just call helper for 0, 0, which means we want to return the added distance between the word 1 starting at position 0 and word 2 starting at position 0 as well. So essentially they are just word 1 and word 2, and we return them. So that's our solution.